Okay, let's dive into this. Welcome to today's Explainer, where we're tackling a seriously massive cybersecurity mystery. For years, the Tor network has basically been the gold standard for digital anonymity. I think a lot of people just assume that the second you boot up Tor, you're a completely untrackable ghost on the web. Like, poof, you're gone. But if that's true, how have intelligence agencies and the FBI spent the last decade consistently busting drug rings, massive ransomware operations, and black market hackers? How are they actually pulling this off?
Which brings us to the million-dollar question. Did the FBI actually crack Tor's encryption, or did these users simply expose themselves? I mean, it's so easy to picture this room full of government supercomputers just brute forcing the math behind the dark web, right? But as you'll see, the truth is way more fascinating and honestly, a lot more human. The Tor network itself, it offers incredibly robust anonymity. Getting caught usually has absolutely nothing to do with breaking that encryption.
It's all about a classic bait and switch. The FBI's core strategy usually doesn't even bother trying to crack the Tor network itself. Honestly, that's a fool's errand because Tor's cryptographic architecture is exceptionally strong. Instead, they target the person sitting behind the keyboard. The real vulnerabilities aren't hiding in the cryptography. No, they're found in the user's web browser, their operating system, their daily digital habits, and, of course, their money flow. So let's break down exactly how authorities exploit these everyday weaknesses. We'll start with the most common technical takedown method. Section 1. Browser exploits in piercing the sandbox. Let's look at the 2013 Operation Torpedo, directed against the Freedom Hosting Network. You gotta remember, at its very core, the Tor browser is fundamentally built on Firefox, and that means it can have unpatched, exploitable bugs just like any other browser. In this case, the FBI deployed what's called a Network Investigative Technique, or NIT. This is essentially just a highly targeted, malicious JavaScript payload. When a user opened a compromised dark website, boom, the script executed instantly. Step 1, it exploited a known vulnerability in Firefox. Step 2, it completely jumped the Tor software sandbox. Step 3, it grabbed the user's actual real-world IP address. And finally, Step 4, it quietly beamed that real IP straight back to an FBI server. Just like that, completely bypassing the encryption, a massive number of users were unmasked in one fell swoop.
But, well, what if there isn't a browser bug to exploit? That brings us to Section 2, traffic correlation, the statistical attack.
Now, this attack is wild because it relies on global surveillance rather than local hacks. I want you to imagine a major intelligence agency simultaneously monitoring the encrypted internet traffic leaving your local internet service provider and the traffic leaving a Tor exit node somewhere else on the planet. Even though they can't read the actual data, the shape of that data is totally intact. So if the packet timing, the packet size, and the flow patterns match up perfectly between your ISP and that Tor exit node, they can statistically deduce that you are the person using that specific Tor circuit. When you factor in that these massive agencies have access to global surveillance, undersea cable monitoring, and ISP cooperation, man, this statistical attack becomes incredibly potent.
And the network manipulation actually gets even more direct than that. Because the Tor network is completely open and public, literally anyone can set up a relay server. And yes, that includes law enforcement. If you're routed through an exit node that's secretly controlled by an agency, and you're visiting a site without standard HTTPS encryption, that exit node can read everything. They're seeing your raw HTTP content, your tracking cookies, your passwords, the whole shebang. Plus, if an attacker controls a large chunk of guard nodes, which are basically the entry doors into the Tor network, they can pair that access with the traffic correlation we just talked about to drastically decrease your overall anonymity.
Okay, let's pivot away from all this high-tech cyber warfare for a minute. Section 3, human error and the fall of the Silk Road. Time and time again, the absolute biggest dark web takedowns aren't the result of some brilliant technical masterstroke. No, they're the result of surprising clumsiness by the criminals themselves. To really get how these dark web empires fall, we have to talk about a critical concept, OPSEC, or Operation Security. Essentially, this is the continuous process of identifying and protecting critical information and digital traces that an adversary could use to uncover your identity. Because in the cybersecurity world, having perfect, uncrackable technology means absolutely nothing if your personal OPSEC is sloppy. Take Ross Ulbricht, the infamous founder of the massive Silk Road dark web market. He thought he was completely invincible using Tor and Bitcoin. So how did the FBI actually catch him? Well, it definitely wasn't a quantum computer. First off, in the very early days of building his empire, he promoted the Silk Road on a regular, totally public coding forum. And in doing so, he left behind a standard Gmail address. Strike one. Next, he reused the same distinct usernames across a bunch of different web platforms. Strike two. And this brilliantly illustrates the ultimate failure. He carelessly allowed his real-world identity to intersect with his dark web identity. The second that happens, your OSPC collapses. Tor didn't fail Ross Ulbricht. Human error did. Which transitions us perfectly to our next major vulnerability, Section 4, Following the Money and the Blockchain Illusion. You know, there is this huge, fatal misconception in the criminal underworld that using cryptocurrency somehow guarantees you total financial anonymity. Let's just completely shatter that myth right now. Bitcoin is a public ledger. Every single transaction forever exists on the blockchain. It is quite literally a permanent public record of every single time money changes hands. Law enforcement agencies absolutely love Bitcoin. They leverage advanced blockchain analysis software. They subpoena know-your-customer data from the big mainstream cryptocurrency exchanges. And they use really sophisticated wallet linkage techniques to build out these complete, sprawling financial maps of dark web enterprises. So the crucial point is what happens when these two vulnerabilities, bad OPSEC and public blockchains, actually collide. Even the most careful, totally anonymous dark web user eventually has to interact with the real physical world, right? They have to cash out their crypto at a real bank to pay rent, or they have to physically receive a package. The FBI relentlessly exploits this exact bridge between the digital ghost and the flesh and blood human being. Just look at how many physical world breakthrough points exist for investigators. Your carefully crafted digital anonymity immediately shatters the second you have to receive physical goods, like shipping contraband to a real postal address. It shatters the moment you turn on a burner phone and ping a local cell tower with a SIM card. It breaks when you carelessly log into a standard cloud account and leave routing metadata behind. And we definitely can't forget social engineering. The FBI frequently poses as buyers, sellers, or partners in undercover encrypted chats just to slowly extract real-world details directly from their targets. Eventually, you have to step outside the matrix, and that's when they get you. And if you thought all of that was intense, check out this next tactic. This is literally the ultimate honeypot. Often, when the FBI successfully seizes a dark web platform, they don't just immediately slap a huge seized banner on the homepage and shut the servers down. Instead, they quietly take over the site and just keep running it themselves. They'll operate it for weeks or even months, secretly gathering login credentials, monitoring private messages, and planting those exact NIT malware attacks we discussed earlier on unsuspecting new users. They turn the criminal underworld's own infrastructure into a massive surveillance trap. It's wild. With all these incredible tracking capabilities and vulnerabilities laid out, you might actually be wondering why anyone uses this technology at all anymore, which brings us to Section 5, an eternal battle, and why Tor still matters. It's so essential to understand that Tor does not automatically equal crime. Fundamentally, Tor is a tool for privacy, and in many cases, literal survival. This is exactly why the developers at the Tor project work tirelessly in this eternal cat-and-mouse game to constantly patch browser flaws, update their sandboxes, and fight digital fingerprinting. For investigative journalists, political dissidents, whistleblowers, and everyday citizens living under high-pressure authoritarian regimes, the Tor network isn't a tool for buying illicit goods. It's an absolute life-saving necessity for secure communication. It protects network-level anonymity, which honestly remains a fundamental human right in our digital age. Which brings us to our final, underlying truth. Modern tracking doesn't need to crack encryption. The final thing that exposes you isn't an IP address. It is you. Technology can mathematically guarantee the secure transit of a data packet, for sure, but it can never patch human error, fatigue, or just simple laziness. Authorities don't need some magical decryption key. They just need to stitch the fragments of your digital life together, patiently waiting for you to make that one fatal slip in your OPSEC. The greatest vulnerability in any system will always be human nature. Thanks for exploring this explainer with me today. It really makes you rethink every single digital footprint you leave behind, doesn't it?